Hello everyone. So I'm going to give you introduction to how to use ORCAD or Pspice software for the lab simulations. This version is very new, so of course you need to use the virtual network. And once you have access to your virtual network, you will be able to see here a folder called Cadence. From Cadence, I want you to go to Cadence PCB. This is like 2020 software, so it's very new, even new for your instructors. So let's see here, what do we need to select? Here we need to select Capture CIS 17.4. And you could choose either one, and I would just select the first one we have here and just click OK. As you see, this is very new, updated software. It's 2020. Now, once this open here, we would be able to see how can we draw and simulate logic gates and logic circuits. Now we're going to go to File, and from File, we're going to make new project. When you make new project, make sure you check this mark here, which is Enable Pspice Simulation, and then give it a name, and you have to select where you want to save your work. All right, so let's say I'm going to give it like Experiment 1, and then click OK. We already have this file, so let me give it another name then. Let's make it Tutorial 1. And then you have to select this, create a blank project after that. Okay. Now you will see the schematic screen here. And with all these buttons here, we're going to see how to use the menus we have here, like the top menu and the side menu. Of course, we're not going to cover everything. I'm going to cover whatever we need for maybe Experiment 1 and 2 and so on. The first thing we need to do here is we need to add component to our experiment. So for example, when you go here, all the components we need, whether digital component, electronic component, exist here. But before you add component, you need first to add something called add library. So if you click here, add library, we just need, like in the first, I would say 2 or 3 experiments, we just need 2 libraries. All right, so the first one is the 7400, and this contains most of the ICs we need. So you need to, I already added them before, but what you need to do, you need to select the 7400 library here. So this here has all the IC components we need, like all the logic gates we need. And then you need also to add something called source. So if you scroll down here, you're going to find another library here called source. So just 2 libraries needs to be added. After you add them, you just select them, open, and then OK. They will be added, and you'll be able to see them in here. All right, what will be the next step? The next step is we're going to simulate logic gate. I'm going to show you one example of how to simulate logic gate. And let's start, for example, if you take a look here, you're going to see here we have an inverter. And if you, there are different kinds of inverters. Also, if you take a look here, this is the AND gate and so on. So we have all the logic gates here. Just keep scrolling down and you'll be able to find different kind of logic gates we have here. This is the NOR gate and so on. So what you need to do here is just select the logic gate that we're going to use. For example, let's say I'm going to start with, let's say, we could choose just any of these gates here, but I'm going to start, let's say this is the NOR gate. All right, so let's have the NOR gate here. All what you need to do is just to click, double click on it, and then it will move with your mouse as you see here, and then just place it in here. And if you want to exit the mode, just click escape. Let me zoom in so it will be more clear for you guys to see. All right, now we have the gate. Next, we need to have the source. How would we assign waveform to each input we have here? To assign a waveform, this is going to come from the source library here. So if you click on the source library here, you're going to find different kind of sources. The one we are going to use for digital logic, it's called STIM1, all right, or STIM1. This is the one we're going to use. So just double click on it, and we're going to need two of these because we need to generate, this will allow you to generate waveform at the input. So we're going to need two of these here, one here, and let's say one here also. So one for each input we have. Next, what you need to do is you need to do the connection between all these components or the wiring. For wiring, you are going to go here to the right menu and you're going to place wire. So just click here and draw a wire from DSTM to the input we have here, and also do a wire connection here. All right, how would I know my connection is solid? If you click on this and try to drag it, as you see, so you don't see any disconnection. So you can make sure that this is properly connected to the gate. And similarly here, so this one also it seems like properly connected. And also I could move this, see here, it's connected to the wire, so I know my connection is solid. And then I'm going to add also a wire at the output. So now we add a wire at the output and the wire is connected well. Next, what we're going to do is, there is something called net alias, which enables you to rename the input and the output. For example, let's say I want to have this A, B, and the output is X. So I'm going to click on this here, and I'm going to give it a name A, and I'm going to have this on this line. So this line is A, and let's say here, but of course, let me just delete this. We need to assign B here, for example. So let's click again, and now let's make it B. And the output here, we need to make it, let's say, X. So let's make it here X. All right, next, what we need to do is we need to assign a waveform, or we need to prove the truth table for the circuit we have here. So let's see how can we do that. First of all, let's draw or write the truth table for this circuit here, and then we will be able to see how can we assign it here. All right, the truth table, if we start here, let's say this is A, this is B, and X, this is NOR gate. So 0, 0 will be 1, and then you have 0, 0, 1, 0, 0, 1, 1, 1. All right, as you see here, for this case, we're going to get 0, 1 when I have 0, 0, and anything else should be 0, all right, because this is the truth table for NOR gate. What we need to do here, how can I generate these signals? All right, I'm going to start with B. To generate signal B, you need to have 0, 1, 0, 1. So the waveform here would be, let's say 0, then 1, then 0 again, and then 1. All right, when you generate the signal, you have to specify the time. So let's say I'm going to start 0 at 0 second, and then I'm going to have 1 at 0.5 millisecond, And then I'm going to transition again to 0 at, let's say, 1 millisecond, and then go back to 1 at 1.5 millisecond, and then go back to 0 at 2 milliseconds, all right? So what we are doing here, we are specifying the signal. And now we're going to learn how to specify it here for the two inputs. For A has, as you see here, it has slower frequency, right? So B change 0, 1, 0, 1, this one 0, 0, 1, 1, so it's slower frequency. So if you want to draw it, it's going to be like we get 2 zeros and then 2 ones, right? If you take a look now at this is your truth table, right? So 0, 0, you get 1, 0, 1, you get 0, 1, 0, you get 0, 1, 1, you get 0. So you will be able to observe wave X after you run the simulation based on that. Now what we need to do here I could say this here at 0 second, I have 0. And then here, of course, this is double the period, as you see. So this would be here at 1 millisecond, I get 1. And then let's say here at 2 milliseconds, we switch again to 0. So that will allow you to achieve your truth table. So basically, you are going to have 2 input signals. One is double the frequency of other, right? So B is faster than A, it has double the frequency. Now let's see how can we specify these signals here. What we need to do here, let's start by specifying, I would say, B first. Just double click on the element. And what you're going to see here, let me first remove this annotation. And now let's try to put what we have just seen in the waveform. So this here is B. So I want to have 0 at 0 second, and at, let's say, 0.5 millisecond, I'm going to have 1, and then at 1 millisecond, so MS stands for millisecond, I'm going to have 0 again, and at 1.5 millisecond, let's say I'm going to get 1, and at 2 millisecond, I will get 0, right? So this here will achieve B, which is 0, 1, 0, 1, as we see here. After you do that, all what you need to do is just we could save this, or if you just close this menu we have here, it's gonna ask you to save that. So I would say just don't warn me again. We just click yes, and now we set the first input we have here, which is B. Now let's go back to A. A, as we said before, is going to move at a slower frequency. So at 0 second, we're going to get 0. And at 1 millisecond, let's say we get 1. And at 2 milliseconds, we're going to get 0. So that means from 0 to 1 milli, it would be logic 0. And from 1 milli to 2 milli, it would be logic 1. All right, so we are done now setting like this part. Now what we need to do is also we need to save this. Just close it and it will be saved. What we need to do now, we need to simulate. Before you simulate, we need to add something called voltage marker. So the voltage marker, we can find it here. This here voltage level marker. Just add one at each line, one here. And another one here at line B, and another one at X. So that will allow you to see the waveform generated by AB, which you already set them up, and observe the output X. Next, we're going to go here to start a new simulation file, just one click here, give it a name. So whatever, let's say digital logic 1, whatever name, and inherit from none, and then click create. After you do that, this another window will pop up, which is this window here. In this window here, it asks you what kind of simulation you need. We're going to do something called transient simulation. So runtime 2. If you remember, the period we added, it was like 2 milliseconds when we set the input. So just make it run to 2 milliseconds. And all what you need to do is just click OK. The next step, now this one will be activated. So first I click this, second window will pop up to make the simulation profile, and then you run Pspice. Just click run. When you click run, another window will pop up. If there is no problem in the simulation, you will get no error. When you take a look at this window here, of course, it seems like still simulating. Let me check again. Yeah, it seems we the voltage marker were somehow erased before we run the simulation. So what I'm going to do is I'm going to add the voltage marker again. All right. So let's go back here again and try to add the voltage marker. So we have here. Let's add one for A. One for B, and one for X, the output. What we need to do next, since we already set up the simulation, all what you need to do here, just click run Pspice. Now when you run it, that's what you will see here. You see A, B, and X. What you notice here is same as the truth table. So when we have 0, 0, the output is 1. When we have 0, 1, the output is 0, 1, 0, output is 0, 1, 1, output is 0. So now we were able to prove the truth table of the NOR gate. We need to do that with all other gates in a similar manner as we have seen here. All right, thank you all for watching.